the important part is you do not have to consider the O2 part, because O2 has a double bond here. VSEPR theory only is based on the sigma bonds and it does not consider the pi bonds. Hello everyone and welcome to my channel. So what question we have today? So today's question is SF4 is isostructural with. Now isostructural, I hope you understand this term. Isostructural means very simple, that should have the same structure as the given compound. So we have to, out of these 5 given options, we have to identify those compounds, those molecules which have the similar structure with SF4. And to solve this kind of problem, let us first understand that what is the structure of SF4. Now, as it is, this question is related to the geometry of the molecules, so we will obviously apply the VSEPR theory. In my previous videos also, I have elaborated how we apply the VSEPR theory rules to get the geometry of the complexes. So I will mention here in short, and if you want to understand the VSEPR theory elaborately, then you can refer to my Udemy course, Advanced Structure and Bonding in Chemistry. Okay, now let's focus on the SF4 structure. First of all, we have to find out the total number of electron pairs, and that is equal to the number of valence electrons of the central atom. So here in SF4, sulfur is the central atom. And you know very well that sulfur belongs to the oxygen family. So the number of valence electrons should be 6. So we have this general valence electronic configuration as NS2NP4, and therefore the total number of valence electrons should be 4 plus 2, 6 for oxygen family atoms. And then how many number of electrons are gained through the surrounding atoms? So we have 4 fluorine atoms which are bonded to sulfur, the central atom. So that is the number of electrons gained through bonding is 4. We have 4 bonding atoms. So each donates 1 electron. Now 6 plus 4, okay, and this we have to divide by 2 to get the number of electron pairs. So we have 5 number of electron pairs. And from our knowledge of VSEPR theory, we know that when we have 5 number of total electron pairs, that corresponds to a trigonal bipyramidal geometry or the TBP geometry. If total number of electron pairs is 5, then hybridization is sp3d. Okay, one is 3p and 1d, total 5 orbitals. And this gives the parental geometry or the electronic geometry as trigonal bipyramidal. So 4 fluorine atoms are bonded to the central sulfur atom. So we have 4 bond pairs. And now the number of lone pairs that we obtain by subtracting the total number of electron pairs, this one, minus the number of bond pairs. So we have 5 minus 4, 1. So we have 1 lone pair in this molecule SF4. Now with the electronic geometry of trigonal bipyramidal and with 1 lone pair, so this parental geometry is distorted according to the VSEPR theory. Okay, distorted trigonal bipyramidal, distorted TBP. And this distorted TBP is actually the seesaw shape. The molecular shape for SF4 is seesaw. So now can you see here the seesaw shape of SF4? So we have 2 fluorine atoms in the axial positions. So these are the axial fluorines. Okay, the 2 other fluorines are in the equatorial positions. So these are the equatorial fluorines. Okay, and the lone pair, here is the lone pair which is also equatorially oriented. Okay, and the entire molecule looks like a seesaw, like this, you can see. Okay, so this is the seesaw shape. So we now know that SF4 has a seesaw shape with the parental geometry as trigonal bipyramidal, and the molecular shape as seesaw. Now we have to go through all the options and check which of these molecules have the seesaw shape. So let us check all the options one by one, but this time quickly applying the VACPR theory. Okay, so let's start with option A, BrF4 minus. So bromine is our central atom. So I am marking the central atom with a circle. The general valence electronic configuration for the halogen family is ns2np5. That means how many number of valence electrons? 7 valence electrons. 5 plus 2. So total number of electron pairs, central atom bromine has 7 valence electrons plus 4 electrons are donated by fluorine, neighboring atom. So 4, and we have one negative charge also, BrF4 minus. So that also will be added and then divided by 2. So that is total number of electron pairs is 6 here. Now what is the number of bond pairs? We have 4 fluorine atom bonded to bromine. So 4 bond pairs, and how many lone pairs? So we have to subtract total number of electron pairs minus bond pairs. That is equal to 2 lone pairs. If the total number of electron pairs is 6, then we have sp3d2 hybridization, which gives us the octahedral geometry. And when there are 2 lone pairs in this parental octahedral geometry, then we have a square planar structure. So we have a square planar structure, something like this for BrF4 minus, and the lone pairs are oriented somewhat here axially. Okay, the 2 lone pairs. Okay, and we have 4 equatorial BrF bonds. So 4 fluorines oriented equatorially in the octahedral structure. So overall we get the square planar structure. So BrF4 minus is not isostructural with SF4 because SF4 has a seesaw structure. So option A has to be eliminated. Then CH4. CH4 is a very well-known example. You know it very well that methane has a tetrahedral shape. So I have written all the 4 remaining options. So methane is tetrahedral. Our central atom here is carbon, and the number of valence electrons in carbon is 4. You already know that. So total number of electron pairs 4 plus how many electrons gained from the neighboring hydrogen atoms? So 4 hydrogen atoms, so 4 electrons divided by 2, that is 4. Okay, so total number of electron pairs is 4. That gives us the hybridization of sp3, and sp3 hybridization gives the parental geometry as tetrahedral. Okay, and also there is one thing to be noticed here in methane, that we have the number of bond pairs is equal to how many? There are 4 hydrogens bonded to the central carbon. So bond pair is 4. How many lone pairs? Do you see any lone pair? So if we subtract the total number of electron pairs, which is also 4, minus bond pairs, that is also 4, that gives us lone pairs equal to 0. So there are no lone pairs in methane. So it adopts a perfect parental electronic tetrahedral geometry. Okay, so the option of methane is also eliminated. So methane is also not isostructural with SF4. Now let's move to IF4 plus. So what is the central atom here? Yes, iodine is the central atom here. The number of valence electrons in iodine belongs to the halogen family. So 7 valence electrons. Number of electrons gained from the neighboring atoms. We have 4 fluorine atoms. So 4 electrons. And also you can see there is a plus charge. That means minus 1. That is loss of 1 electron gives it a cationic nature. And then divided by 2, that is equal to 5. So we have got the total number of electron pairs as 5, gives sp3d hybridization. And this sp3d hybridization says that it has a trigonal bipyramidal geometry. We have 4 fluorine atoms bonded to iodine. So it has 4 bond pairs. How many number of lone pairs? So lone pair is equal to total number of electron pairs 5 minus bond pairs 4, that is equal to 1 lone pair. Now, when we have this trigonal bipyramidal electronic geometry with 1 lone pair, then it becomes the distorted trigonal bipyramidal or the seesaw shape. So you can see the seesaw shape in IF4 plus. So it is overall having a plus charge. So we can write it like this. And it is absolutely isostructural with our SF4 molecule. You can go back and check. We have SF4 molecule here with 2 equatorial fluorine atoms and 2 axial fluorine atoms and a lone pair which is equatorial. So we have seesaw shape for SF4 and seesaw shape for IF4 plus also. So we have got one option which is the correct answer, IF4 plus. So C, part C. Yes, IF4 plus is isostructural with SF4. Then let's check XeF4, xenon tetrafluoride. The number of valence electrons in xenon. Xenon belongs to the noble gas family. So it is Ns2 and Np6. 8 valence electrons. Okay, 8 valence electrons, 4 fluorine atoms. So 4 number of electrons which are gained from the neighboring atoms, and then we divide it by 2 to get the 6 number of total electron pairs. And when we have 6 number of total electron pairs, then our geometry becomes octahedral, and we have sp3d2 parent hybridization. So xenon is bonded to 4 fluorine atoms. So number of bond pairs for XeF4 is 4. How many number of lone pairs? So we have 6 total number of electron pairs. So 6 minus bond pairs minus 4. Okay. So we have 2 lone pairs. When we have the parental octahedral geometry, but we have 4 bond pairs and 2 lone pairs, then we have the square planar geometry. So you can see here the square planar geometry of XeF4. I have drawn 4 equatorial fluorine atoms here and 2 axial lone pairs. Okay, so since it is square planar, this is also not isostructural with SF4. So this option is gone, CH4 is gone, XeF4 is gone. And now we are left with XeO2F2. Number of valence electrons in xenon is 8. As you have seen here already in XeF4, we have 2 oxygens and 2 fluorine atoms. But the important part is you do not have to consider the O2 part, because O2 has a double bond here. Okay, that means O2 contains a pi bond. Oxygen is pi bonded, and VSEPR theory only is based on the sigma bonds and it does not consider the pi bond. So this is an important thing to remember here, that in any of the molecules where the oxygen is doubly bonded, we do not consider it as a part of the total number of electron pairs in that molecule. So we will proceed with 2 fluorine atoms, not the oxygen atoms. So 8 plus 2. So we have got 5 electron pairs. Total number of electron pairs is 5. So now you know that when the total number of electron pairs is 5, then we have sp3d hybridization and trigonal bipyramidal geometry. How many molecules are bonded to the central atom? Xenon. Here also you have to be careful when you calculate the bond pairs in those circumstances when we have a doubly bonded atom. For bond pairs, we have to consider the contribution of the oxygen molecule. Why? Because oxygen contains sigma as well as pi bonds. Okay, so we cannot ignore the contribution of the sigma bond that the oxygen has while bonding with xenon. So it has a sigma bond and a pi bond, and through that it is bonded to xenon. So we will consider the contribution of that sigma bond with xenon. We will add up both O2 as well as F2 while we write the number of bond pairs in these conditions. So bond pairs will be obviously 4. 2 from oxygen and 2 from fluorine. The number of lone pairs. So we have 5 total number of electron pairs minus 4 number of bond pairs. So lone pairs is equal to 1. Now when lone pairs is equal to 1, in the parental trigonal bipyramidal geometry, then we have a distorted trigonal bipyramidal geometry that is known as seesaw. So now you can see here that I have drawn the seesaw structure for HCO2F2. The two fluorine atoms are placed axially. Then you can also see we have two doubly bonded oxygens which are placed equatorially. Lone pair which is oriented equatorially on top. HCO2F2 is also isostructural with SF4. Out of these 5 molecules, we have IF4 plus and HCO2F2 which are isostructural with SF4, because all of the three SF4, IF4 plus and HCO2F2 have a seesaw shape or molecular geometry. So our correct answer will be C and E only. So I hope you understood this explanation, and if you have any doubts or queries, please write to me in the comment section, and please do not forget to like, share and subscribe if you find my videos helpful for you. Till then, thanks for watching, keep learning and see you soon with the next problem.